Welcome to the first lesson of a topic titled Real Zeros of Polynomial Functions. Lesson 4a is all about long and synthetic division. We'll learn how to divide polynomials using long division. We'll learn about the remainder theorem, a shortcut to find the remainder, and the biggest idea in this topic, synthetic division. I'm Mr. Stark, and this is Polynomial and Rational Functions. Let's start dividing. Long division of polynomials is what we'll study first, so let's make sure that we know how to do long division of numbers. It takes me way back to 3rd and 4th grade. Those were the days. Let's do 1,333 as our dividend and 11 as our divisor. One way to do long division, the way that I learned, is to put the dividend inside the box and the divisor on the outside of the box. The first step is to find out if 11 goes into 1, which it does not. Then find out if 11 goes into 13, which it does, one time. We multiply 1 by 11 and we write that product below the 13. Then we subtract. 13 minus 11 is 2. Then we drop down the next number, the 3. Then we find out how many times 11 goes into 23, which is 2. We place that 2 above the next number. 2 times 11 is 22, and 23 minus 22 is 1. Then we repeat the process one more time. 11 goes into 13 once, 1 times 11 is 11, and 13 minus 11 is 2. We can make a few conclusions based on our long division. First, the quotient is 121. Second, the remainder is 2. And finally, 11 is not a factor of 1,333 because the remainder is 2 and not 0. When we do long division with numbers or polynomials, the dividend is equal to the product of the divisor and the quotient plus the remainder. So let's make sure we know what's what and we did the division correctly. The dividend, 1,333, is equal to the divisor, 11, times the quotient, 121, plus the remainder. 11 times 121 is equal to 1,331, which happens to be 11 cubed, and then we add 2, and we get 1,333. Excellent. Knowing the algorithm and the vocabulary is really helpful. Now let's use long division to find the quotient and remainder when 2x to the 4th plus x cubed minus 3 is divided by x squared plus x plus 1. Let's make sure we know what's what first. 2x to the 4th plus x cubed minus 3 is the dividend, and x squared plus x plus 1 is the divisor. So let's put the divisor on the outside and the dividend on the inside with placeholders for x squared and x because they don't show up in the dividend. Just like long division of numbers, we want to find out how many times x squared goes into 2x to the 4th. In other words, what do we have to multiply x squared by to get to 2x to the 4th? Well, that would be 2x squared. So I write that above 2x to the 4th. The next step is to multiply 2x squared by the entire divisor, x squared plus x plus 1. So we get 2x to the 4th plus 2x cubed plus 2x squared. And just like long division of numbers, we subtract the entire expression we just found. 2x to the 4th minus 2x to the 4th is 0, so we don't write that. X cubed minus 2x cubed is negative x cubed. And 0x squared minus 2x squared is negative 2x squared. Just like in long division of numbers, we drop down the next term, which is 0x. And that is the first iteration of this long division. Notice that the focus of the division is the first term of the divisor, x squared. The other two terms, x and 1, were accounted for when we multiplied 2x squared by them. Okay, round 2. What do we have to multiply x squared by to get to negative x cubed? Negative x. Multiplying negative x by the divisor, we get negative x cubed minus x squared minus x. And we have to subtract that entire expression. So we get negative x cubed minus a negative x cubed, which is adding an x cubed. So we get 0, but we don't write it. And negative 2x squared minus a negative x squared is a negative x squared. 0x minus a negative x is a positive x. Then we drop that negative 3 down. That is the second iteration. We have one more. Okay, round 3. What do we have to multiply x squared by to get to negative x squared? That is negative 1. So negative 1 times x squared plus x plus 1 is negative x squared minus x minus 1. Subtracting that entire expression, we get 0, 2x, and negative 2. And we're done, because the last term, negative 3, was dropped down in that previous step. Therefore, the quotient is 2x squared minus x minus 1. The remainder is 2x minus 2. Remember, the dividend can be written as the product of the divisor and the quotient plus the remainder. So let's do that. 2x to the fourth plus x cubed minus 3 is equal to the product of 2x squared minus x minus 1 and x squared plus x plus 1 plus the remainder. In a more general form, we could write that as f of x equals d of x times q of x plus r of x. F, d, q, and r are polynomial functions in terms of x. In a few moments, we'll learn how to do synthetic division, which is a shortened version of long division. But first, I'd like to tell you about the remainder theorem. It's a theorem that helps us find the remainder without actually doing long division. It goes like this. If polynomial f of x is divided by x minus k, then the remainder is f of k. Meaning, if we divide a polynomial function by a binomial in this form, x minus k, such that k is a real number, then all we have to do to find the remainder is plug in that k value into the function. So let's try it out. Find the remainder when f of x equals 2x squared minus x plus 12 is divided by x plus 3. So we have a polynomial function, but that binomial is not in the form that I shared with you. So I'll rewrite that as x minus negative 3. Now we can plug in that negative 3 into the function. When we do that, we get 2 times negative 3 squared minus negative 3 plus 12. And that's equal to 2 times 9 plus 3 plus 12. Therefore, the remainder is 33. And since the remainder is not 0, we could also conclude that x plus 3 is not a factor of f of x. That leads us to the factor theorem. The factor theorem says that f of x has a factor x minus k if and only if f of k equals 0. If and only if means that statement works both ways. If f of x has a factor x minus k, then we know that f of k is 0. In reverse, if f of k equals 0, then we know that x minus k is a factor of f of x. Now it's time to learn synthetic division, a shortened version of long division. This algorithm only works when we're dividing by a binomial, so we wouldn't apply this to the very first example of long division. The general setup looks like this. We put k in a box and write the coefficients of the polynomial horizontally. We also write a horizontal line and then apply the algorithm. If you're interested in how long division was modified to become synthetic division, you should check out a textbook. What I'm about to show you focuses on the process, not the origins. So let's divide 3x cubed minus 2x squared plus x minus 5 by x minus 1. Since x minus 1 is in the form of x minus k, 1 goes in the box. The next thing we'll do is write the coefficients of the polynomial horizontally. 3, negative 2, 1, and -5. Just like in long division, if there are any missing terms, such as x squared or x, then we would write a 0 as a placeholder. We'll leave space for another row of numbers and then write a horizontal line. We drop the first number down, and I usually draw an arrow. That step represents 3x cubed being divided by x. There's a 3 involved. Now we multiply that 3 by the k value and write the result underneath -2. So we write 3 because 3 times 1 is 3. Then we add -2 plus 3, which is 1. So far, you might have noticed that the few steps that we took were opposite of long division. All of the signs are opposite. X minus k, so we put a k value in the box. In long division, we subtract. Here, we add. Now let's repeat the process. 1 times 1 is 1. 1 plus 1 is 2. And let's repeat one more time. 2 times 1 is 2. -5 plus 2 is -3. That -3 is the remainder when we divide. The 2 is a coefficient of x to the 0. The 1 is the coefficient of x to the 1. And 3 is the coefficient of x squared. Notice that we divided a cubic function by a linear function, a function that has a degree of 3 by a function that has a degree of 1. Therefore, the quotient should have a degree of 2. 3 minus 1 is 2. Specifically, the quotient is 3x squared plus x plus 2. The remainder is -3, so we write the remainder over the divisor. We do the same thing with numbers. 3 divided by 2 is 1, and the remainder is 1. So we could write 3 divided by 2 as 1 and 1/2. Okay, that's the synthetic division process. I want you to remember two main things. When we divide by x minus k, then k is what goes in the box. K can also be understood as the 0 of that binomial. The other thing is, when there are missing terms, be sure to write a 0 as a placeholder. And that's it for Lesson 4A of the Polynomial and Rational Functions unit. I'm Mr. Stark. Join me for the next lesson, Lesson 4B. Did you press that subscribe button yet? Give me a thumbs up if you liked the video. If you have a question, you might as well ask it. Do you have a comment? Feel free to add it. Hey, thanks for watching.